Hi everybody, this is Sam with Python Basics, and welcome to our 1000th video. So let's see, we got a couple people here, but what I really want to go over, if there are no questions, I really want to talk about this stadium problem, but I really am hoping that we're able to kind of go through this together. So I do have our moderator here, and let's see, and you'll have to forgive me, I have not live streamed in a very long time. So let's see if let me make sure everything looks good. All right, and I have not recorded in the daytime, so hopefully the lighting is not too badly. Not too bad. I had to rearrange a few things. I thought it was going to be a little darker outside, but so all right. And let me check one more. Okay, good. Got it. Okay, so all right, we do have a couple folks here. So well, let me just kind of open up the floor. Is there anything anybody wants to talk about, look at, needs help with before I jump into this stadium exercise? Because that's kind of what I really want to go through and kind of walk through how this came about and how then I worked through making the decisions and how I arranged this. So let me mute my phone, or at least put it on vibrate. Okay. All right. I think okay. If there are no questions, I don't see anything in chat, and do we have anything in Discord that you see, Jan? Okay. All right. Well, then I'll just go ahead and go and get started. So let's see. Do I want to? All right, cool. You posted that over in the general chat. Thank you. All right. All right. So let's go through this stadium problem. So how this came to be was it's actually originated in Discord, that someone was working through a problem, and I kind of slowed down because I found out they were going through it on a test. So I gave them thoughts to think about, and that's really where that I want to take this channel, is how to restructure how you think as a person to how to then think as the program. Not just a programmer, but what does the program need to be successful? So let's look at this stadium seating right here. So here's the image, and then we're going to slowly migrate it over to Python. So we have rows and columns. So what the question was stated was, this is a stadium right here, and the zeros are empty seats, the ones are occupied seats. And if you had a group of three, you and two friends, how many different seat combinations could you have if you were going to sit side by side? So now let's take our human brain and go through each of these, and then let's slowly begin. Well, actually, let's see how this translates into Python brain. So here's an exact replica of the stadium seating. And if we begin to see, we've turned it into an array, or a list of lists. So that's step one from human brain to Python brain. So all right, let's go back here. So now let's begin to attack the problem. So we know we have a group of 3. All right. Then, and they can overlap each other. So that starts, if you've had problems like this before, you know what to do automatically. But we're going to do human brain right now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. All right. Cardinal, awesome. So glad to have you here. So for I hope this is okay, Cardinal. But for everybody who is here and is on Discord, Cardinal is the one who contacted me and asked if they would be willing, or they were willing, and if I was willing to let them help me set up the Discord. So the Discord is all Cardinals. My son asked when I learned how to do it, and I said I did. I had a very nice helper reach out, so props to Cardinal, and thank you very much for that. So all right, okay, I digress, but super glad to have you here. Oh, we have a few more folks. So let me just say, if anybody wants to jump in and needs help with they're stuck on something, go ahead and pose in chat or over on Discord. We have folks watching. Should remember, like 16. Yes, it is. Yes, it is 16. Correct. So we have our human brain, how we went through, and then we're beginning our Python brain. So these were actually the variables that we got in the question. So we have the seeding array, we have the size, and then the grouping. Okay. So that's how we knew to go and count groups of 3s. So now we have and this is then one of the things that I did to begin to move over to Python brain. Because at first I was, well, actually we're gonna do this grouping, and then I'm going to show you how to make this dynamic. So right now we're going to make this static set in place, and then we're going to make it dynamic. So we need some zeros. 0, 0, 0. Oops. And you're also going to get to see that I'm not that great at typing. Gotten a lot better over the years, but still not that great. And we need a counter. Just realized, skipping counter, because we want to count how many, because the original problem, the original ask was how many groups are there? But in reality, there are, if we were going to build this as like the beginnings of an application, somebody who's searching for this, they would want the seat number. So we're going to first go ahead and see how many groupings. And then if we have time and there aren't any other questions, we're going to actually then go through and see and assign seats, so we know which seats to actually then go and purchase. All right. So here's our stadium. Here's our size that we get. We could work with this, but we're gonna we could actually derive this on our own, but we're gonna use this, and I'll show you why in a few minutes. And then here is our length. And so we've created this statically. We are going to use this later again if we have time for a dynamic search, because we could, what happens if this was 2? What would it be? So okay. Excuse me. So now, so we have this in do we have this in memory? Let's see. I think, well, now we do. So let's just begin to look at this. For I in seating, print I. Okay, so I get each of my rows. Well, what are we actually checking for? We're actually going to go through each of these, beginning here, checking the next 1, 2. So wait a minute. We know how to do that. So if I want to check this, and check this, well, wait a minute. 1, 2. So this is a slice. Wait a minute. Is this a slicing problem? So, all right. So now I've got this first one. So I have a list of lists. So I have a nested list. So I need, so we have 5 times 6. So we have 30. So look, what? So for I in seating, for J in I, print J. Aha, wait a second. 1, 2, 3, 4, 5, 6. And that should be 1, 2, 3, 4, 5, 6. So just here. So wait a second. So now I've gone through and I've printed out each individual one. Well, okay, so I now know how to do this. What I really need to do is I want to check this against, so why didn't I pick that one? Well, because it wasn't 3 zeros. So, but we're going to still look at it. We're still going to compare it. So we need to go through each one of these and take a look. So let's do that. So we already know how to look at it. So why don't we go row in seating. Let's make sure print row. Let's make sure we're doing this correctly. All right, so we have row. So now let's print out seat in, oops, for seat in row. Now we're getting close. So now we are so what do I get now? I get my same example right here. Oh, wait a second. So I need to go through here and have it be this and these two. So wait a second. I know how to do this. We need to change this a little bit. We need to do this for here, or index 0. Wait a second. So because what we're going to do is we're going to use the indexes, and then that's actually going to help us and set us up for our seats. So all right, let me do this, and then we'll look at it and see why I did this. We're going to change this. So here, let's go back. So all right, I'm going to change seating to right here, because 1, 2, 3, 4, 5. So instead of me going down here and calling these rows, it's the exact same. I'm going to use our size and our index here, which is, and we're going to index this. So let's change this. So we're going to do the range on size 0. Now, what I could do is I could have done len. I could do the same here, where I could go range on seating, len of seating, because then I would have gotten the exact same. I would have gotten a 5. So then same thing here. We're going to change this to range, then size 1 right here across, because we have 6. So, all right, let me check and make sure we don't have any questions right now. Yes, so I will get to that in just a second. So good, great question. So what we're going to be doing is, so let's do this. So now, oops. So now here we are with our index. And again, we've converted, now it's like, what is, because we're going to be checking these indexes. So we have 0 through 5, 0 through 5, 0 through 5. Let's see. My son is right. I do need a third monitor. All right. So did that answer your question? So now what we want to do is we want to print out this index, and this index, and come up with an algorithm, and then move to this index, index, and so on, and as we go. And what you'll find out is once we get to here at the end, it's going to shrink, but it won't matter because we're going to be comparing it to this right here. So, all right, let me see. Let me check my notes. So, all right. So now let's see if we can print out the seats, and I've changed this a little bit, so you're actually going to get to see me go through my process. So seats of and what did I do? Oh, we need to add our counter. Counter plus equals 1. So when we match, oops, nope, not right there. That needs to be inside our if. So let's just get these groups to print out. And then, so seating, because these are the index, seating. So then row, because again, this row, so let's see. Now that we've changed this a little bit, so seating index 0, which is now what is happening. So these are going to be indexes. All of these are indexes. So when I call seating index 0, I'm going to get this one. And let's see. Then 0, 1, 2, seating 2, I get this one right here. So as we're going through, because we are staying each inside this, we are always on this row. So this is your first, your row is your first index. So if we wanted this one right here, this would be 0, 1, 0, 1. Seating of 1, 1. It's hard to show exactly, and I don't think I have. Yeah, there we go. So I will be right here, 0, 1, 0, or excuse me, 1, 1. And then to show you, still 1, let's go 2. And it will be a 0. And if I can type as 2, so that is right here, these two. So now I want, this is where it gets neat, seating. Now we're slicing, because we want from here to here, right? And we know how to get this. This is seeding, starting at 0. So index 0, and then we want 0, 1, 2. But for indexing, we have to go, so we want 3. So it's then 0, 3. This is the beginnings of our structure. So it's, seats, and then seats plus 3. So, all right, let's see if there's any questions so far. Okay, cool. So what you'll see, as I alluded to, these ranges will begin to shrink. Oops, I don't want to change anything. Okay, did I not? And then we'll get down to here because we'll become out of index, but it's not an out of index error. So this is to which I was referring. So boom, 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 boom. Now, of course, this will not match our 3 right here, nor will this one, nor will that one, nor will that one. So let's go through this. So here was our first, second, third, and fourth right here. So this is the beginnings of this algorithm, because, and then of course right here, so we just came up with our structure right here. That is our group of 3 that we are testing. So that would not pass because it's not 3 zeros. That would not pass because that's not 3 zeros. Okay, now we're back to this. And if we look, that's right here, which is our first group right here. All right, any questions so far? All right, cool. And again, look, if you have a question, somebody else has a question, so please jump in. And hopefully after we get done, there will be some time for open questions of anybody who's working on anything and I would be more than happy to help. Okay, very cool. We have, if I'm reading this, I haven't done the live streams in a while, but if I'm looking at this correctly, we have 8 on right now. So that's very cool. Okay, let's see. So let's get back. Let's get back here. So, all right, let's comment this out. No problem. Great question. So let's just kind of jump back. So what the question is, what are we doing right here? So this is an example of a question that somebody posed on Discord. And this is an example of a stadium. Zeros are unoccupied seats, available seats to be used. 1 is an occupied seat. So what we are doing, yep, might get a little loud here. I got some kids moving in and out of the house, and the dogs don't like any noise, so forgive me for the background noise. So what we're doing is we're going to derive an algorithm that is going to look for, as of right now, 3 empty seats put together. And this is our structure of how we're going to find a group of 3. And then we're going to be comparing this to grouping. So let's do that. If grouping equal to counter plus equals 1. And then print counter. So if I did this right, we should see this go up from 1, 2, all the way to 16. So here we go. This is the basic setup to answer this question. So we have done that. So now why don't we actually go one step further, because we have quite a bit of time Awesome. Thank you, Jan, for answering that. So we have quite a bit of time. So what I want to do is I actually then want to show you how to make this dynamic. So right now, this is static. Well, we're going to do both, because I still haven't shown you how to get the seats. So let me look and check my notes to see what we did. So if we were to actually make then, yes, we counted the 16 groupings, and sorry if I'm squirmy. I tweaked my back yesterday, so hopefully I can sit here for an hour. I'm looking over. Hope the lighting is right. Like I said at the beginning, I am doing it at a different time of day, so I tried to tweak the lighting, so hopefully it's not too out of whack. So let's see. All right. Line 280. Sure, absolutely. Let's go back. Let's go back here. So, do you get line 279? So what I did right here, this is our algorithm of which list, and then our group of 3. So do you get, I just want to know how far back do I need to go? Do you get line? Okay. All right, so let's do that. So what I'm doing here is this is the equivalent of which, because this is a nested list. Let me see if I can move this over. If I move this over, does that make it a little more clear? So this is a list of lists. So you have, it's nested. So right now when I do seeding, I get this. But if I call seeding and I do our first index, I get an entire row, but it is also a list. So if I wanted to check right here, so if I go seeding and I check this first one, so seeding 0, 0, I get this first one. But what I want to do, what I really want to do is I want to check this one, and this one. Whoops. I want to check these 3. So for me to slice this, I need to go seeding. Actually, let's just do this. 0. Then I need to go 0 plus 3, because I need to get over, because remember, when we're slicing, we get an index. It is exclusive. So 0, 1, 0, 1, 2, or the equivalent of 3. So what I'm doing here, because don't forget, 0, 1, 2, it is exclusive. So I'm checking here. So seeding, let's redo this. All right. So this is the equivalent. And this is probably more what you're used to seeing. Let's put this up here. I'm pulling this first index, this row, and then I want to see, so if we were to change this, row 1 equals seeding 0, row 1, then I do slicing of 3. This is the equivalent. So this is how you handle nested lists. So if you need to convert this over, where you need to then make an arbitrary variable to set this, so the indexing, because after you do it for a while, it begins to make sense. But seeing this, I completely understand how foreign that looks. This begins to look a little better, and what you're really probably used to at this point in your journey is this right here. So you're slicing. We want to slice parts, sections of this list. And this is how we are handling that right here. And then what we're doing on 280 is we're then comparing. Here, let's run through this again. Put this out here. So basically we're going to be checking. And what I did is I wanted to print this out so you could see it. We're going to be checking which of these meet our criteria of 3 zeros. And every time it happens, when we do our if statement right here, so if you look, let me slide this over just a little bit. All right, can you see that more clear? So if you look right here, this is the exact same as this. So I'm doing a comparison, an equivalency test for grouping, which then happens to be right here. So every time this, an output, or an iteration, excuse me, an iteration matches grouping, I want you to count by 1. Okay? That's what we're doing on 280. 279 is a visual representation of what we're checking for. Did that help? Okay. All right. So let's continue. And fantastic question. So we can comment out right here. Then we go back and we have our 1 through 16. So we're getting kind of close, but what we do not have is awesome. Wonderful. Thank you for the feedback on that. And if we, let's see. So now what happens if we wanted, so now this is also where this is going to come in very handy because we're already indexing. So we have our row and then we're going to go and get our seat. So let's see how we're going to do that. Yeah, we're still going to keep our grouping. We don't want to, there we go. Let's comment that out. So now, let's see, we're inside our grouping. So now we're gonna create an empty list. And this is actually what threw me off when I was creating this, is that I had, wait a minute, do I use, let's see, I don't need that in this example. Let's get rid of that. So let's create, yeah, seats. And empty list here. So these are an example. This is what seats are available. Sorry, I haven't looked. Okay. So what seats are going to be available? So let's just go ahead and look at that. So let's come seats. And now this is going to be a little uglier, and then we're going to make this very dynamic. So this is building on this right here. And we're going to need to then adjust. So we know indexing. What we're going to need to do is adjust for, hang on a second. I need to test something because I did not. Let's see. Okay, does that work? Yep. Okay. So we're gonna need, and we're gonna need to move this over a lot. All right. So then we're gonna do row +1 and a seat +1. Now why are we doing it this way? Well, we know about indexing. So this is index 0, but it's also row 1. And this is right here. This is index 0, but it's seat 1. So we're shifting this over for somebody who would be using this. And then did a lot. Did not know it went that far. Oh yeah, because this is the non-dynamic. So let's think about this. So we're not going to adjust. This is the equivalent of right here. 0, then 0, 1, 2, and we need to go to 3 for exclusive. So seat 1, seat 2, and seat 3. All right. I know that can be a lot. Any questions about that right now before I continue? What am I doing right here? Does everybody get this so far? Okay. So we're adding to the index to make it more human. Let me check and make sure this is showing, right? Okay, good. Sorry, I didn't check earlier. All right. Go back to this, make sure I don't miss any questions. Why only row 1? Perfect question. Because this is in this row. So we're not adjusting down every row, just every time, because we're staying and we're sliding over 1, 2, 3. So this is the equivalent of these right here, because we're slicing. So it's 0, 1, 2. But in indexing, we have to go one above. So it's just basically, what is it? What do I want to show you? Oh, len of seating. 1, 2, 3, 4, 5. So then if I do seating, this is the one example that one, two, three, 1, 2, 3, 4, 5. But this is where we want to go and do 6. So see how that, because this is going to be kind of like this, how we're going to go out of range, but it's not going to cause any issues. So this is a length of 5, and we 0, 1, 2, 3, 4. So that's why 5, it's the length of, I think I'm going down a rabbit hole right now. But we're not moving rows. That's why row stays the same. Just like right here, the row stayed the same. We're iterating through the seats. So every time we get to this row, we're just going to check these 3, then these 3, then these 3, and these 3. And actually, if what we found out is in our algorithm, it then checks what would be these 3, which there are none. So that's why it's only a group of 2. And then these 3 over here, which again, it's out of index, but it doesn't, the beginning index, and this is what took me a while to understand why these algorithms are fine, is as long as the beginning index is within range, it's fine. Your end point can be out of index, and it will only produce, that's what I'm trying to say, it will only produce the number, the output that is within index. But if I were to start here at 0, 1, 2, 3, 4, 5, 6, then I would have an indexing error. But since I'm beginning, and this is also why I like the range technique, is because you're allowing the program to be in control of the beginning index. Now, if we were to try to count and keep up with this, we could get into a problem and be out of index very, very quickly. So I know I said a lot there. Did that help or make things worse? So let me go back to find my spot, and hopefully I made things better, not worse. Because what we're doing is we're appending, if we look right here, a list of lists of the actual row and seat, so we know where we can sit. So then if I come here and go, why do I have an error? Undefined seat. And this is why I like this program very much. So I was not using the correct variable. So I was using seat instead of seats, and this is also going to throw an error. Let's change this back. Seat, seat, seat. There we go. All right, let me make sure seat. Yeah, I need to change all these. Sorry guys, this is an example of you seeing me work through this, and this should be here, seating there, row there, and seat. Oop, I want seat. All right, good. Everything looks good. Now let's get this output for row in seats. Print row, and then print len of seats. So what am I doing here? Okay, so the out of range error doesn't show up when manipulating a list inside another list. Okay, I'll answer it this way, and then you tell me if so your end point can be out of index. Your beginning point cannot. So as I showed right here, there is no index. So 0, 1, 2, 3, 4. So if I do index 5, so when I do len of seating, I get 5. But then when I call 5, I get the entire list of lists. But if I call for index 5, it's out of index. But since and then as I said, I started to show here. So if I call, again, I want this last, so 0, I don't know if you can see my cursor, index 0, index 1, index 2, index 3, index 4. But here, that's the whole thing. For in range 0 to x, x can be out of range, but 0 needs to be non-nan value. It needs to be an available. So right here, so the index 0, 1, 2, 3, 4. So I get the last row. Let's bring this over a little bit. Let's bring it back. So here's my last row. But if I go 5 to 5, I'm out of index because 0, 1, 2, 3, 4. There is no fifth index, because that's where it gets a little tricky between slicing and indexing. So I'm slicing here. This is slicing because I have a colon. This is indexing. So as long as my start, so the range function and indexing are the same. Let's see if you guys can see that. Let me make sure. Let me check this. Sorry. Cool. Start, stop, step. So indexing, if you ever forget the rules of indexing and slicing, it is the exact same as the range function. Start, stop, and step. So when your starting point is inclusive and your stopping point is exclusive. So it's excluded. So whenever we go 0, 1, 2, no, don't move that. It is, so when we say 3, it's right here before, let's see how well it shows up. Okay, good. That is right here before, excluding the third index, but everything backwards. So 0, 1, 2, not 3. So there, let me go back to chat and see. Okay, finally. Oh, awesome. Well, good. This is going a lot better than I thought. So now that we have our little algorithm, and I think we're going to be okay on time. Let's see, what am I getting? I'm throwing an error for built-in function. Let's see. Seats.append. I'm appending that. Okay, what is the difference between... We may be about to, because... Let's see, does this throw an error? And you'll get to see how I work through things. Nope. There's an error in here somewhere. Let me see. 0, 1. This works. Maybe copying and pasting here in a minute, everybody, so you can see. But this, okay, seating, got grouping. If grouping, well, we know that works. Then we have seats.append. Ah, did anybody catch it yet? I made a very big boo-boo. I have a function here that I have not created. So what I did is I actually was missing my append, and whenever you have a function or a method, you have got to have your parentheses. So that's what I left off. All right, so now let's look at this. Okay, so what do I have here? This is actually the seats. So 1, 1, 1, 2, 1, 3. Boom. Then 1, 2, 1, 3, 1, 4. Boom. And then I have this counting, and I'm counting. So right now, as I created a empty list, and then what I did is I'm appending and dropping in a list of what my seat combinations are. So fourth row seat. So 1, 2, 3, 4. 2, 3, and 4. So boom, that's a combination. Then my last set of seats is row 5, then 5, 5, so 5, 5, 4, 5, 5, and 5, 6. So now, this is all kind of cool, but I want you to look at this. What would we do if the problem said 2 or 4? We would have to come in here and change absolutely everything. Okay, so 16 is no for combination of seats available to user in given fashion. 16 is number, not no. So yes, correct. That was where we counted up, where we took our human brain and we counted up the groups of 3 zeros that were side by side that we would be able to sit, and that is 16. So then we took and derived an algorithm that then enables us to turn this loose and go and not only count, but then give us an output of what seats in what row and what seat is available that we can purchase. So now, like I said, this is static. This is not, because if somebody were to come through and say, oh, we need it to be 4 now, well, we'd have to come in here and add more seats here, change this to a 4, and then change our seating. So let me begin to show you how you would go and do that. So we may be a little over an hour. Hope we keep everybody. Let's see where I am. Okay, so let me get my notes around. Okay, so first of all, let's copy this and turn this. Let's comment this out. So this is going to, of course, stay, but this is going to change. So I'm going to show you something very interesting. So we have n equals 3. So n times look at this. We just made our grouping dynamic right here. So let's shrink this down. Why won't that shrink? Interesting. Lost the bracket. Then times n. So now my grouping is here. So when we change, let's say we change to 4, and then I go grouping, boom. Okay. So now we have part 1 done. We have our grouping. So let's change this back to 3 because we know that's 16. So now we need, what else do we need to change? We need to change this. Now that this part down here is going to get really cool really fast, and we'll go through it. So now I need to change this to n because, again, our slicing. So this needs to be dynamic. So this is dynamic, our size of our grouping, and then our dynamic of our slicing. Does everybody get those two parts before we get to this? Because this is where this gets very cool very fast and can get very confusing very quickly, because we're going to need to then add another group because our group size is going to change. So let me just ask, everybody good before we get into this part? Line 300. You want this again? Perfect. Thank you for asking. All right. So what am I doing here on line 300? So we are making, this is the information we get in the problem, and we were given the n size, the size of the group was 3 people, but we hardwired this here. We hardwired this in. So 3 empty seats. Now, if we wanted to make this so we could change it, we need to make this dynamic. So if I do 3, I'm creating a list right here, a index. So let's see. Let's change this up. So grouping equals times n. Grouping. So that's now what happens if I change n equals to 2. I make it the size of 2 zeros. Then if I make n 4. So then here I am. So I'm creating a variable that creates a list of whatever size groups of 0, however many zeros in that list. And I know this can be very, very challenging and it looks so obscure, but this is a very handy technique. So when I go and I make zeros, I close this out and I'd multiply this by 5, I just created a list of 5 0 strings. All right. Did that help? All right, let me check because I'm getting ready. Okay. I'm gonna keep going. All right. So now we need to adjust this because this is not dynamic. This is static. How did you arrive at 0 if it is dynamic in the sense of this data set, but can vary accordingly? Oh, okay. Why am I choosing this? Because this is a list of a length. So basically, okay. Python understands that I want to put together 5 of these lists. So here, let's look at this a different way and see if this helps. Times 2. So Python will take this list and create a new list, multiplying it by over and over and over again. So now I've taken that list and I'm telling Python, combine them, and I want 2 of them. So we want a list of the contents. So we're telling Python, I want a new list of 2 of these of this contents inside a list. So that's why it does not turn into a list of lists of this occupancy. It is however many times of this. So like we did right here. So I have 5 strings inside this. And here, since there's 2, I want 2 of these. So now I get 1 and a complete duplicate 2 because I'm multiplying it by. Did that help any? All right, let me get ready for this last part. So I now am going to make, because I need to come up with a way to be able to repeat however many seats that I need. So I'm creating a group here. All right, let me see. Awesome. Glad that helped. All right. Anybody on Discord dropping anything? I haven't checked over there. All right, cool. All right. Let's start to wrap this up. But this is going to get really weird really fast. So let's comment this out. We do not need that. So now, for I in range 1, and then n plus 1. And I'll go over what I'm doing here. So I'm starting at 1 because we're having to, what do I want to say? Because we've already adjusted for the indexing. So this is why I'm starting at 1. So this is seat 1, so this is an index. So range automatically defaults to 0. So that's why I can't say go through n plus 1. So this is the equivalent of this. So seat 1. So we're already handling the indexing issue right here of 1. So then 1 plus n plus 1 to get us, it's the equivalent of this, 2 and 3. So however many seats, again, is. So seat 1, 2, 3, because n plus 1, because we're indexing here. So that's why this is going to look so weird. So then I'm going to add that seat. So if, and I've already handled if this group, right? So I've inside this group, so I'm going to iterate through this because I've already checked that this group is 3 zeros, excuse me, is an unoccupied seat that fits in our grouping. So then I take group and I append. Then I'm going to append the row. Again, still just like I had, oops, close that. No comma. Then seat. Then plus I. And I'll explain this in just a second. Seat dot append dot group. All right. Okay. This is where it can get really weird. So let's come up here. So here are my seats, right? So this is inside this. So I'm making a new group, this right here. So if we were to look at, all right, 311. Great. All right, let me do this first and then we'll get to 311. So this right here on this I wish I could. There we go. So this is group. So here, right here, this is the equivalent of that one with our brackets. Then we're creating each seat inside our group. So that is the equivalent of this one right here. So we're going through and we're making this dynamic. So the number of seats as we're going through, we're adding that seat. So this is the equivalent of each time through here. And that is going, we're appending each seat like we did here inside group. And the reason why we're doing it this way is because we don't know how many seats we need. It depends on this. So it will need to go through and check each seat. And then what we're doing on 311 is this right here. So then we're dropping that in seats. So if we were to look at here, let's bring this in here. Append, let's see, where am I making my mistake? 311. You may have actually already spotted the error. That might be what you're trying to tell me very politely. Yes, that is. There we go. Okay. So when I call seats, if we look, this is This is more. This is a list of lists. So it's 3. If we look at 3 brackets, because here is our seats. Seats is a list. Then inside of seats, there is a group of 3. And inside that, each group of 3 has a list of a seat row and a seat number. So that's what we're doing right here. We did it the longhand way, statically. And in here we are doing a dynamic way. And let's see. Oh, we did do it right here. So the reason what I want to show is, so with 3, there are 16 groups available. If we do 2, there are 21 groups available. If we do 4, there's only 11. Let's see. I don't know. Did I do 5 and 6? There's 6. And let's say if there's a group of 6, I think there's only 2 rows. No, 3 rows. 1, 2, 3. So there we go, guys. Did that help with 311? Is it Mayor? Okay, let's see. Well, if there are no more questions, please make sure, if you guys haven't jumped over to Discord, make sure you're doing that. We have a wonderful community over there. Oh, fantastic. I'm very glad to hear that. We have a wonderful community over there. Great admin, great moderator, and I'm so glad that they have been able to be here today. And Cardinal, I will make you a mod for any future live streams. I did not even think about that, so that is an oversight on my part, and I apologize. But please, if you are new here, please make sure you're hitting that subscribe button, notification bell, dropping any comments, video requests. I hated that. I enjoyed doing this, but I hated that we weren't able to answer any very specific questions to you, because your Python journey is very specific to you. But before we end out, I just want to ask again. Yes, I've got everything. Thank you. Oh, you are more than welcome, and thank you everybody for being here. I have thoroughly enjoyed this. But as always, guys, thank you so much for watching. Stay tuned, and we'll see you next time. Bye, guys.